maxima and minimum problems. In Calc 1, when we talked about maximum and minimum problems, we talked about the idea of derivative, and we found where the derivative equaled 0. And that derivative that equaled 0 was considered a critical point. Another critical point was where the derivative was undefined. And those two conditions, either one, once we found that derivative, would tell us that that was a critical point. And then we'd have further analysis that would tell us if that critical point was a maximum or minimum. So that's kind of where we're starting here. We're going to get into the multivariable calculus and what that looks like for these critical points. And that's our first definition. It says here, let z equal fxy be a function of two variables that are defined on an open set containing the point x0, y0. The point x0, y0 is called a critical point of a function of two variables f if one of the two following conditions holds. So when I look at this, I have fx, or I would call it partial derivative of f, equals the partial derivative of y equals 0. So really what this is saying is where the gradient of f equals 0. Or it says this for the second condition, either the partial of f or the partial of y does not exist. So just as I was talking about calculus 1 here, because we're dealing with multivariable calculus, we have two components to consider here. We have the partial of f or the partial of y, instead of just one derivative when we're in calculus 1 with two-dimensional surfaces or two-dimensional planes. So now let's take a look at this first problem. It says, for the following exercises, find all critical points. So the first thing we're going to need is we're going to need our partial derivatives, because in either condition, we're going to need a partial of f or a partial of y. So that's what we're going to do first. So when I take this function f of x equals 15x cubed minus 3xy plus 15y cubed, I'm just going to find the partial, so fx. And I'm just going to use this notation for it. Hopefully that's okay with you. So 45x squared minus 3y. And this is going to be 0 because it's with respect to x. And that's just a constant. All right, and then fy is going to be negative 3x plus 45y. So those are our partial derivatives. Now think about what we're looking for here, critical points. So it's going to be where these both equal 0. Now this means here that the fx equals xy equals 0, so that means they both have to equal 0 at the same time. So what that means here is I have these two equations. So we just set them both equal to 0. And then what we have here is a system of two equations, two unknowns. So what we can do is we can plug one into the other. Oh, this should be a 45y squared. I'm glad I caught that squared there. Be careful. Make sure it's on yours. Okay, so that's what we have. So in most cases, when we have a system of two equations, two unknowns, the one that we usually use that always works for almost everything is substitution. So I'm going to take and solve one for the other. So that means I'm going to move the 45 over to the other side. And I should move the 3 over. So this, what I mean by that is I'm going to get 45x squared. And I'm just going to use this first one. Equals 3y. Let me fix my 3. Then I'm going to divide by 3. So then 15x squared equals y. And what I'm going to do with this is just sub it into the other equation. And I'm going to find out where they're both going to be 0 at the same time. So for y, I'm going to plug in 15x squared, which is going to go right in there. All right, so this is going to be negative 3x plus 45, and then my y there is going to be 15x squared, because I got this little 2 up there, and that's what I see here. All right, oops, put it back. Equals 0. So now I'm just going to multiply all this out and try to find the value for x. So negative 3x plus 45, and then I got to take 15x squared. That's going to be 225. X to the fourth equals 0. So now I need 45 times 225. So that's going to result in negative 3x plus 10,125 x to the fourth equals 0. So now in order to solve this equation, I pull an x out. I'm just thinking factoring here. So I pull an x out, and I'm going to have negative 3 plus 10,125 x to the third now equals 0. So now what I'm going to do here is I get two equations from this. My first one is x equals 0. That's said and done now. Now I move on to the next one where I really have 10,125x cubed, and I'll say minus 3 equals 0. So now from here, I got to solve for that x cubed. So I can move the 3 over and divide by 10,125. Now when I move it over, I end up with x cubed equals 3 over 10,125. And then when I simplify that, 3 goes into both of those, which is nice. I get 1 over 3,375. And then when I cube root both sides, I get x equals 1/15. That actually worked out really nice. So it's x equals 1/15, x equals 0. Now we have some of the makings for our critical points here, because now we have to find out those y values. Now this is two x's that resulted in 0 when you think of both equations being 0 here. So now I have to find the y values of those. So that's what we're going to do now. So we can plug it into either one of them to do this. I'm going to plug it into this one down here because it's already been modified for us. It's going to be easy to plug in 0 and 1/15 into that. It'd be the easier two. So that's what I'm going to use there. So when I plug it in for the first one, x equals 0, I'm going to get y equals 0. Because when I plug in 0 here, that's easy to see. For the next one, for x equals 1/15, that means I'm going to get 15 times 1/15 squared equals y. So honestly, once I do the math there, I can see that this is going to be 15 squared down here. So one of those is going to cancel. So I'm going to end up with 1/15 for y once I do this math here. And try it out. Test me with that one. So now I actually get the 2 points. And those 2 points are going to be 0, 0, and 1/15, 1/15. So those are my critical points. Call them CP sometimes for short. So there's the answer. Now later on, we're going to take those critical points and determine, are they going to be maximums or minimums or something else? And that's what we'll find out in videos to come.